Hi, my name is Steve Rahi. I am a Premier Field Engineer specializing in management technologies. Today's discussion is part 5 of an ongoing series talking about SQL Server for non-SQL admins. Calling out Config Manager 2012 applies for sure beyond Config Manager 2012. This session really focused on programming SQL. So the agenda for the session here really want to start basic level of understanding for working with SQL, move to the complex, and then add a little bit of layer of additional complexity, and then talk about a couple of advanced topics, mainly because I didn't want to use the word complex again, and then we will be finished. And so as I get into this, let me say that while there will be some concepts introduced, there's really no way that I can try to cover it with any kind of uh, sense of completeness all of the different options for various commands that you'll see. Very much like a programming language, it'd be very difficult to cover all iterations. Can give examples, and then for your specific scenario, can work with those examples to figure out what needs to happen. So let's just dive right in with basic, right? So the most basic SQL query is a select statement. Select statements are a great way to start to browse your database, understand what's in the database. Select is a read-only operation. It's safe. You can use it to look at data wherever you want to in the database, and as long as you have rights, obviously, and do so safely because we're not going to make a specific change based on a select. Right. So just some examples here as we go through. Start with the most basic, select star from Northwind accounts. So this example is just simply pulling out all of the data from the table called Northwind accounts on the database that's selected where you run the query. So there's a drop down in the SQL admin console where you can choose the database under which you will execute this query, right? So this is very simple. It's just going to open up that table. If there's 10,000 rows or 100 rows or 20 columns or whatever, it's going to dump all of that into your view, and you can work with it, right? So the most basic query there is. We can add complexities to the query. As we see, the second one would adding on a bit of a filter, select star from Northwind accounts where name equals Tom. So you might have that 10,000 rows or whatever, and you might have 5 or 6 instances of someone named Tom. And so instead of returning out the many thousands of rows, we would just simply return those few where the name equals to Tom, right? And that would reduce your set, do an effective filter on it, and so on, right? Now, SQL would still have to do the work of going through the table and making sure that we know which ones are rows where the name is Tom, but we can present that to you in the view. Makes it a bit more focused to work with. And the third example is just building upon the second, select star from Northwind accounts where name equals Tom, order by last name. So here's just adding this a little bit more. You could have 4 or 5 different Toms, Tom Jones or a Tom Arnold or a Tom uh, Campbell or whatever, right? And so you would want to maybe lift out all of those Toms and then sort them by the last name for a better appearance. And that's one thing to think about as you're designing these queries. One of the things that ConfigMgr people would care about in terms of queries is being able to represent that in a report, that data set in a report perhaps, and build custom reports. Well, having the ability to do groupings or filterings of the data can make the report set a lot more friendly, right? A lot easier to look at or aesthetically more pleasing, right? So being able to filter by Tom, order them by last name, alphabetize or whatever, we can do that. Now there's other tags here too, don't have here, so you could order by last name and then put a capital ASC, which means ascending. So you can tell it how to order, either ascending or DESC, descending, right? You can do that too as part of a select statement. All right, so the select statement is the only one that's read-only. Uh, the next one is delete. So be very careful with delete statements because we will do exactly what you tell us to with a delete statement. Now, there's some conditions in which the delete may not execute because of something called constraints, which I'll talk about in a bit, and maybe some other factors, but the delete statement is really straightforward as well. So notice that we have the delete from. There's no qualifying criteria at this level, like there was with select. Delete from the table Northwind accounts where value is less than 10,000. So with this one, it might be a scenario where you're trying to purge old records from the database, customers that maybe are not maybe top tier customers. They don't reach a certain valuation, whether that's monetary valuation or some other scoring that is used by the company. Whatever it is, the delete statement is what it is, and the delete statement here also can have some additional criteria put on it, as you see. Delete from Northwind accounts where value less than 10,000 and age is less than 1. So maybe it's an additional filter you want to add, and you only want to get rid of those customers that are brand new and don't have a certain value reach. Maybe there's older customers that are kind of grandfathered into a new program. Whatever the case is, we can make them up all day, but that's a delete statement. And again, be very careful with it because we're making changes to the database through the delete. Next one is the insert. So insert is also making changes to the database as a result of running the query. So two versions of this. So insert is just adding data to the table. So you see simple enough, insert into Northwind accounts values, and we list out all the values. But the question is, where are these values? What are they? How do we know what's being entered into the database? And the answer is, from this query, you don't really. You might know the table very intimately, and so in that case you would. But the way this works is there are 5 columns on the Northwind accounts table. You can actually look down here and see that. So SQL is able to interpret, since we have 5 columns and we have 5 values, that it's just column 1, column 2, 3, 4, and 5 in sequence. Now that's not always true, right? You may not always want to enter data into all 5 columns. So that's where you can use this kind of syntax. Insert into Northwind accounts. We actually call out the column names, and then here we specify the value. So it's easy enough to know that 45 goes into the ID, 45,000 is revenue, Alex is the first name, Roger's last name is 17, is the years as a customer. Right. Now, again, pretty simple example of an insert statement. You might be in a scenario where you're inserting 1 column or 2 columns worth of data into a database that has 45 columns on this particular table, right? And you can do that too if you craft your insert statement the way you need to. This insert statement wouldn't be effective to insert just 2 columns worth of data. You would need to use a format like this. All right, and then update. So update is not adding anything to the table per se, it's taking an existing entry and changing it. So I guess you could argue that that is adding, but the data, there was at least data already there. Now we're changing it. So you can do this again a couple of different ways. Update Northwind account, set revenue equals 0. And what that would do is simply loop through every single row of the Northwind accounts table, and where you have any value or any space or any option to set revenue, which would be a column in that table, it would set all of them to 0. So if you have 10,000 rows in this particular table, then you would now have 10,000 zeros assigned to the revenue column. Right? So be careful with that. That can be an easy mistake to make. A little bit more filtering. Update Northwind account, set revenue equals 0 where revenue is less than 10,000. So this would be an addition to maybe the query we had back here, right, where we're trying to get rid of or adjust certain accounts that don't fall above a certain threshold. So we're going to get rid of them and maybe set revenue to 0 if it's not a high dollar or highly valued customer or whatever. Right? Or another iteration, update Northwind account, set revenue equals 0 where revenue is less than 10,000 and ID is less than 20. Again, more filtering, right? If you just want to act on the top 20 rows, assuming that the IDs are consecutive and start at 1. Okay. All right. So from the very simple to the more complex, right? So we have the select and the delete and the insert and the update statement. So now we can see even more complex examples of using those. So this is a longer one where we're trying to select detail. But as we do the select, there's a few elements in here that are worth talking about. So you see now p.name, instead of just in contrast here, Here you don't see any p dot or anything else. It's just calling out the particular table name. So what does all that mean, right? So notice that p dot is referencing the particular table in which this field comes from. So the from clause references the specific table that you want to use that contains this data. SQL has a mechanism where you can actually alias values. So you might have a really long table name perhaps, and you don't want to have to type that every single time. So you can, instead of referencing the table name by production.product, or even just the shortcut of that, which is product, you could call that table P. And so this P would be translated to production.product, right? And then even this value that comes out of name would be aliased as product name. So whenever the results return, any value in the name field would become a value in a product name field. This is something that happens in SQL views all the time, just to jump ahead a bit, because oftentimes in databases, certainly the ConfigMgr database, data is represented in the tables in such a way that maybe not all the time does it make sense exactly uh, what that data is. It might be in a particular table that references another, and in order to get the full understanding of what that data set is, you have to kind of pull those tables together. And so, there may be a representation where a column is called one thing in the table version, but we need to change that name to something that's more user-friendly in the view or in the query output, and that's where we would alias here, right? Also notice that production.product, this refers to database name dot table name in the database. If you just had the production database selected and you refer to product, SQL knows what particular database that table is in. Or this could actually be schema too, right? So said a different way, in a database, let me pull this in as an example. Here's SQL. So in a database, you will have a number of tables, very likely, certainly in the ConfigMgr database, that are referenced with the schema, right? So dbo dot something, dbo dot something. And dbo is kind of an understood thing. You don't have to specify it. But if you do drill down a bit further, you'll see tables that don't start with dbo. They start with their own classification, their own schema. So sccm underscore ext. If I tried to do a select star from that, let's do it. Star from, make sure my table or my database is selected. Select star from, I'm just going to use this one right here, okay? And I could just type in, actually let me go up for it first to a DBO extension and do it. So you see DBO, so I can just type in select star from, I'll use Windows Update Data. You see that we find the table, we know exactly what table it is. I can execute that, I get data back, no problem. But then if I try to do that same thing for one of the tables that's referenced under the different schema, sccm underscore ext, scroll down a bit, I'll just do alert 00. I can select star from alert underscore 00. And you see that SQL is not able to resolve what table name from here. If I execute that, it will say, I don't know what you're talking about. But if I simply go to the front of it and put in sccm underscore external or extended, now I know exactly what reference is for that table and where to go get the data. Did I type something wrong? Let's see, alert, oh, DD, that's my bad. You saw it in the list. Yeah, alert DD. So we resolve it. We can execute against it, no data there, but you get the idea, right? Okay, so what else can we learn from this particular query? So we're doing the select, notice we're doing non-discount sales equals, and we're calculating. So we're actually selecting a name of a column that is going to only exist after we calculate it as we go through the query. So this is a calculated entry. So its discounts is calculated as we go through right here, right? Other things we can do as we build some of these queries and so on. Notice there's an inner join here. So joins we'll talk about in a minute, but essentially joins is a way to take your query and have it span multiple tables, right? And so you can have the data in a format that is appropriate for a relational database where not everything is stored in the same table, and then you use joins to pull those data sets together as you need to on the fly, right? And then again, order by how we will present the data, and you see the DESC tag. Right? Another example of a more complicated query, delete from, and again, purchasing.purchase order detail, where the purchase order detail is in this query. So this is kind of called a sub-select query or a embedded query or whatever, right? So the very first thing, order of operations, apply here just as well as they do in math. So the items enclosed in parentheses will execute first. So the first thing that has to happen is we're going to query or run this query and store it in memory, and then we're going to delete based on the results of this query, right? Okay, insert statement, same way. So we can insert into the new employee table, which is part of human resources. And what we're going to do in order to know what to insert, we're going to use a select statement, right? And tell it what database we're going to insert to, and then use inner joins to grab all the data that we need, right? So again, a bit more complexity, but the basic concept of the query is the same. Update, same way. So here we're going to update the sales staff. We're going to use some variables, if you will, or set some values, not variables at this point, and then use a select statement and so on, right? So we're going to update all of these based on a select statement and so on, right? So enough of that. More complexity. So in a query, you can use wildcards. So in Windows and DOS and whatever, the wildcard is an asterisk. In SQL, the wildcard is a %sign. So these two queries would actually return different values. So select star from Northwind accounts were named like %OM and %. So this would reach out and pull any record that has OM in the name, right? So it could be Tom, it could be mom, it could be whatever ends in OM, or common or whatever, right? Whatever has OM in the name. This one is a bit more specific. We want specifically the names that start with TOM and end with anything else. So it could be Tom, it could be Tommy, it could be Thomas, TOMAS, whatever. We would get all of them, right, with the %. And you can use this in many places. You can use these %, wildcards, and update statements and delete statements and all over the place. Right? Parentheses. So the parentheses are again operator order of operations type commands. This is a select statement that is a sub-select statement. So the first thing we're going to run is what is in the parenthesis. Select name from Northwind account holder, and then once we have that in RAM, then we're going to select all values from Northwind accounts where name is equal to the values that are in Northwind account holder. Right? You'll see parentheses getting fairly complex as you embed different queries. Be careful with that, because the more sub-selecting we do, the more processor intensive it is to maintain that data and store it in memory and so on, right? But very possible. Order of operations too, in terms of functions and such. This is maybe a way to enclose your data as you pass into a function or ask the function to do certain things. You'll see examples of some system functions related to date time as we go forward. Dash dash is just a simple way to comment your SQL query. So if you're working to troubleshoot your SQL query and trying to add extra elements and so on, you want to test whether one section of the query is running and others might be having problems, you can put the double dash in front of those sections of the query that you want ignored, and SQL will do that. Or you can exclude a whole query like I did here, or whatever, right? So the double dash is just there as an example of commenting. Finally, the @ sign. So this is a way in SQL to designate a variable. So I'm just going to do an update statement and then set @latest value which is a variable equal to uh, this query result, right? So we're going to run this query to get the result set. We expect one result set that we're going to set latest value to that return, right? And then we're going to go print what the updated value is and specify it out this way, right? So referencing variables as we go along by the @ sign gives us significant flexibility, because now the query can not be so stringently written that it's the same thing every time and has to be rewritten and so on. You'll see variables used a lot in items called stored procedures and functions and so on, right? Okay. All right, so moving from the complex to the more complex, right? Just another few examples. So sometimes in a select statement, you might want to do things like count a set of results and such. So a specific example in the config manager world, I pulled this query from a particular, or from the health, or the RAP as a service offering that we have. This is a query that I found very interesting and useful. I was trying to figure out how would I identify specifically the duplicated MAC addresses in a database, right? There are a couple of examples where that's relevant, and more, that we could expand to if we thought outside of MAC addresses in the config manager world. So years ago, and we don't really have this problem today, but years ago we had the dial-up adapter in versions of Windows. And so customers that use config manager would be collecting all of that information about their network settings on the system, and part of that would be the dial-up adapter that would come forward. Every dial-up adapter on the planet has the same MAC address, and so what would happen is you would end up getting slow processing, because the MAC addresses, the way some of the processing worked in previous versions of Config Manager loading inventory, would take a long time to pull up all of the duplicate MAC addresses and decide whether we're going to insert a new row and different things, right? Detail's not important, but the idea is. Another issue that I think of is largely understood and taken care of now, but on tablets or such, where you don't have an Ethernet port, yet you want to image those tablets, customers will go out and purchase Ethernet dongles. They can plug into the USB port, plug an Ethernet cable into the dongle, and do the image, and that's great. The system is imaged. Now they move on, take that dongle to another machine, try to do the same thing, and ultimately run into issues, because as the config manager client comes online, it's going to inventory, and that dongle is going to be inventoried and sent forward. The MAC address off of that dongle will come forward. The config manager system then that you move the dongle to, that shares the same MAC address, because that dongle is not changed, the MAC address is the same. When it tries to go to inventory, first it's no longer an unknown computer, assuming you're and when it tries to go image, it's no longer an unknown computer if you're using unknown computer support. So you may or may not get an image or a task sequence flagged for you. If you're not using unknown computer support, again, you probably won't get the expected task sequences flagged for you, because that MAC address is known and associated with a different machine, right? So a few elements of this. So select sm.MAC address. So sm is declared here, MAC address ARR, and then we're doing a count of our MAC addresses, and we're representing that as the number of occurrences. So this is the first place we do a count, because we want to display that. Then we do the join over to the system discovery table, and then group it by MAC addresses, and specifically group it by only those that have a count greater than 1. So you might have 100,000 entries in this table, but you only really have duplication with about 100 of them or whatever, and so we're only going to show you the 100 that will come back and be duplicates for you. So let's take this over to SQL and actually run it and see what we get. So I'm just going to paste the query in here and make sure I'm on my database. You see that I am, execute that, and you notice that I get one return set. Doesn't mean that I just have the one entry. It means that I've filtered based on count. So if I exclude this with the comment and run it again, you'll see I have a whole lot more entries. It's just I have one entry with multiple occurrences, right? So by having the having clause, I can filter it to just show me those that I'm concerned about. And so this has implications all over the place if you're worried about duplicates, right? One place that, at least historically with ConfigMgr, that we were worried about duplicates was with the SMS UID. That should not be so much of an issue anymore, but it would be a good place to run a query like this to count up how many duplicates you have, identify those duplicates, and so on. All right, let's move that out of the way. Joins, merges, and unions. So this one is interesting. So joins are commands that are similar to selects. We've already seen some of them. There are multiple types of joins, but essentially a join will take uh, or has the ability to reference data across multiple types of tables and bring them into a single view or result set. Right. So this is an example of the join. So pretty simple query: select star from users. And so a portion of the data that I care about is in users, but I'm going to select all data that is associated with the entries in users. So I'm starting with users, and then I'm interjoining, I'm combining the set of data from users with another table called user security roles. And I'm referencing what table I want to join here. I'm calling it USR so I don't have to keep typing that out over and over again. And then I'm just simply saying, okay, as you look at users and user security roles, make a combination of the tables based on the user ID, which is a common element in both tables. And you have to have a common element in both tables in order to do your join. Now be careful, the common element may not always be the same name. It hopefully will be to avoid confusion, but as an example in the ConfigMgr database, looking at the tables specifically, views take care of this, but in tables, there's an element called item key that references a unique item key assignment to systems. Well, there's another flag called resource ID in a different set of tables. The resource ID is the equivalent to item key, it's just called differently. Another example of the same thing is in even yet a third table set, it's referenced by the name machine ID. So you could very effectively do a join in that case by saying join machine ID equals item key or something similar, right? That's hopefully not the norm, but it is possible. You have to be very careful when you craft this. And then we're joining again, doing a second level join, security roles table, where the security role ID equals, the user security role ID equals the security role ID on the security roles table, and then filtering yet another level and just pulling back those security roles that equal admin, right? So joins can get to be a bit difficult because of all of the tables that we referenced and having to put all of those in RAM. You want to be careful in terms of performance with them, but very, very effective ways to filter your data. There's also multiple kinds of joins as well. So I won't go into them. I would encourage you to look up what they are. There's a full join, an inner join, an outer join. For the inner and outer joins, there are left inner joins, right inner joins, left outer joins, right outer joins. There are self joins. There are cross joins, which tend to happen on the same table. Self joins tend to happen on the same table. All of these work a specific way. So, a left outer join works differently than a right outer join. A left inner join works differently than a left outer join, and so on, right? Don't want to take the time to jump into those, but again, definitely something you can find on the web and would encourage you to take a look. So this is joins. So again, joins are equivalent, just more complex, to select statements, right? Joins don't have to just be used with select statements. You can use them with other kinds of statements as well, but the idea is to use and manage data across tables and multiple tables and so on. Then we get to merges, the merge statement, which I will talk about by first talking about the fact prior to the merge statement, it would be a combination of insert, update, and delete statements to get the same job done. So envision a scenario where you have a database that you're trying to update, keep up to date, whatever, and you need to get rid of some existing data in preference to having new data set in place and such. And so part of that operation would be to delete that old data set and then replace it maybe by some new data or change some data with new flags or whatever. And so the insert, update, and delete statements will help you do that. It'll help you purge the old data, update the existing data, add new data where needed, and so forth, right? The example here, we can kind of walk through. We're creating a table, products, we're inserting records into the product table, then we're creating another table, updated products, we're inserting some data into that, then we can go select values from it, ultimately we can go delete, and so on, right? Just an operation as an example. No delete statements in here, but you can definitely see us reading values into new tables and such that we then might want to massage a bit further. Well, the merge statement does the similar things. This is that same query, if you will, that's in a merge type format. So we're going to merge the products tables, and we're going to be using the updated products. Again, same, kind of thing here. So we created the table products, we created the table updated products, then we're going to do the merge into it, and so on, right? So just a more efficient way to kind of do all of it at the same time in the same transaction. Commented here if you want to go through and understand it specifically. So the merge statement, again, different from joins. We're actually writing data with joins. It's more about getting the data ready to operate on. It could be some writes that you do with a join statement, and so on, right? And then finally, unions. So a union is, again, it's a way to pull data from multiple tables into a single view. Think of a union as a combination of the results of two or more queries into a single result set without the filtering that is available with a join. So we do actually have joins in each of these queries. So here's the top level query, here's the second level query, definitely some order by stuff here, joins within. But on the union, there is no joining on the union itself. The joining is done on the queries, right? And so this is actually a query that comes from a report in the ConfigMgr database. Let me run that report as an example of what this looks like. Let me pull in the lab and go grab that report for a minute. This is the lab where I have reporting enabled. All right, and so I've actually pre-opened the report. It's that's not it. I was using it for something else. Let me go find it. This is it. This is the all content report. That's where that query comes from. And so if you look at data sets and then look at the dataset properties, this is report builder, you see this is the union clause that I've got on the PowerPoint. So if I go run this and just watch how the data returns, I could run this in the ConfigMgr console too, but since I'm here, right, what will happen is the data will be all together, right? We have some operating system images, some boot image packages, some standard packages, and so on. On we go down, right? And get to applications at the bottom, driver packages, so on, applications, and so on, right? So this is a nice view of all of the different deployables in your environment that have content and where that content is located, what distribution point and such, what the package ID is, and so on. But the way this actually gets generated is through this union. And so you can look through this and you see, well, there's some RBAC stuff that we need, but we're joining on the distribution points so that we know what all distribution points are where, what package IDs, and so on. And then we're filtering out by the type of package in this first select. Then we go on down and we're doing some more RBAC work and we're looking at CIs in this specific query, which are the driver packages and are the applications and so on, right? So not to belabor the point, but a union is just that. It allows you to combine data sets. You could have a couple of different queries even beyond this and union them all together if you choose. The one thing to be a little bit aware of is the more you do this, the more performance impact it could have. Not to say don't use it. If you need it, use it, but just be aware that it could have a little bit of performance impact. just like any programming language, there has to be a way to introduce logic into the query process. So this is just a very simple example of an if then else kind of logic that you would find in programming languages. Also introduces the function for date time type stuff, the get date with nothing in the parentheses. So this is just simply saying if the date name, which I'm getting the date name from specifying I want the current, or I want the weekday name from the current date, which I get with get date. If the weekday name is in this list, then it's going to be flagged as a weekend day. If not, it's going to be flagged as a weekday day. Pretty simple query, but illustrates the point. Now you can have queries that get darn complex with the if-then type of logic so that you can direct the flow. Look at pretty much any query probably in our stored procedure set, and you'll see lots of conditionals that have to be satisfied in order for things to flow certain directions, right? Well, having too many if-thens is not probably really an issue, except for the fact it can get visually challenging to follow sometimes what's going on. So there is another logical operator called case, where you can do comparisons in a group a lot easier to organize. So in this case, we're just focusing on different conditions that could exist for a field called list price. And if it's 0, we're going to say, you know, what there is to tell about the item. It's not for sale. If it's under 50, then say it's under 50. If it's greater than or equal to, then say it's under, and less than 250, say it's under 250, right? And so on, right? So you can build this however you want. So what would be a practical application of this in ConfigMgr? Well, so there's lots actually, but the one I think of is in the packages tables, right? In the status tables anyway. You will see package status tables. Let me combine those two. You will see numbers that represent the state of a given piece of content, right? So it could be numerically represented as 0, 1, 2, 3, 4, whatever, right? Well, that doesn't mean anything to the user, perhaps, whenever they run the query or run the report or whatever. So it would be a convenience to be able to interpret that for the user. So maybe if you come across a 0, that means no status, just putting some guesstimates out there. If you come across a status of 2, maybe that means replicating content. If you come across a status of 4, perhaps that means content in place or whatever. So you can use the case statement, focus in on that particular value, and be able to represent it in a way that is more user-friendly in something like a report. All right. All right. Getting more complex again. So variable, declaring variables and such. So here we are simply using a simple example. So I'm going to declare 2 variables: the @name variable and the @username variable, and both of these are going to be strings. So varchar. So the declare block is pretty easy. Just whatever variable name you want, what variable type it's going to be, string, which in this case is varchar, integer, int, XML, whatever it is that you need to reserve memory for the variable. Be careful. With modern computing systems, it's probably not such a big deal, except trying to think through efficiency. But if you don't expect your name to ever be beyond 20 characters, don't assign it 100, because that just reserves more memory space for something you might not ever need, right? And then once we have these values, we can go directly to a select statement, or whatever statement you really want where you can use these. Here we're going to do a select star where name 0 equals this name, and username 0 equals this name. Well, you can see from this that there is not ever going to be, hopefully you can see from this, there's never going to be anything returned from this query, right? Because I'm not setting these particular variables to anything. They're null, okay? So nothing's going to match. Whereas if I use a block called set to set these variables to what I really care about, I can pull back the result set for focus just on these things. So using a set block is one way to actually configure the variables. Couple of points here. So using the set block in a query probably isn't the most practical, except in a couple of scenarios. One, if you are maybe using the set block and using a variable to set the variable, that's certainly possible. Or you're passing in parameters to a particular variable, which that's very common as well. You'll see that used a lot in stored procedures. Or the third thing, if you have a query that you're trying to manually debug, so you expect in practice that variables will be passed in or parameters will be passed into the variable, but here you're trying to execute the query manually, right? So you can actually use the set block to supply the values for the variables, run through the query, troubleshoot it, make sure it's working correctly, and then once it's finished, take that out and let the parameters pass in the values. Right, let me show you an example. So let me just pull in the lab real quick. And I've got both these queries here. So I can run both of them. Syntactically, they're fine. But this is not going to return anything because there's nothing that we're going to match. There's nothing that's going to return whatever. Yet whenever I do set the variables here, we're going to return the result that you saw just a second ago, if you paid attention down here, filtered on Win7 as the PC name and administrator as the username, supplied by variables. All right, let's pull that back out. Okay, so making it a little bit more complex there, so going to the stored procedure side. So working with stored procedures, it's very common for stored procedures to have variables, and those variables uh, must be defined by parameters that are passed in to the stored procedure. So here I have just the header of a stored procedure used very commonly, MP get content DP info protected, right? And here we're expecting certain things. We're expecting a couple of string values up top, an XML blob, some other kinds of detail, another big XML blob and such, right? So how do you know? Because it could be advantageous to be able to run stored procedures manually. How would you know what to do to run the stored procedure? Well, one thought might be, well, let's use the logs in ConfigMgr to tell what is being passed in to that stored procedure. That's a very reasonable thing to do. In fact, that's what I did in this middle block is I just captured in the MP underscore location log in ConfigMgr this particular stored procedure getting called. You can see all the parameters that are passed in, right? But the challenge is this doesn't work, right? So in order to make it work, you would need to understand how to format things correctly. You could also try to use Profiler and see how that comes out. But here I've just modified it a bit to be able to run this stored procedure manually. That is very, very useful for troubleshooting things. And sometimes just by tweaking some of the values that are passed in, we can kind of understand where some of the problems are. So let me show you these two. Pulling back in the lab now. So here are both representations kind of spelled out. You can already see the top one has a number of places it's called out, syntax errors, whatever. If I try to run it, won't do it because it's not formatted in a way that the stored procedure will accept. However, if I go run this one, it will absolutely run, no problem. Doesn't have any data coming back, not a big surprise. But you notice the differences here. I just formatted things a bit differently. I knew by looking at the variable list that this was going to be a string, so I put it in single quotes, and then new numbers were good. So here's another one that I put in single quotes because it's a string. Roll on over, we see the XML tags starting over here. Put that in single quotes. Now SQL will actually accept double quotes in some cases, but you typically want to use single quotes. The reason this would kind of not work here at all, even if it might otherwise, is in an XML blob, we have the double quotes in here. So that would kind of confuse SQL if we put double quotes out here, right? And so, just knowing how to tweak these things to get them to run manually is helpful, again, in troubleshooting and scenarios similar. All right. Moving on. All right, so stored procedures and manual execution, just went through that, right? So one thing I will say on stored procedures before I move on. So there is the parameters list, there is the manual execution that we can go through. Stored procedures, the question sometimes comes up, at least in my mind, why do we actually store queries in stored procedures? So in the ConfigMgr world especially, if you do tracing on ConfigMgr logs and so on, you will see that in some cases, the SQL operations will be called with a query directly, a select statement, an update statement, an insert statement, whatever it is. And at other times, the code will call a stored procedure. The answer really is maybe not 100% true in the config manager world, but where we have repeatable code that we can supply parameters, variables, and such to drive that code, very oftentimes a stored procedure might make sense. Right? Not all the time, so evaluate it carefully. Uh, the other thing is stored procedures. Any query that you run goes through two stages. At first is optimized by the SQL optimizer to try to be as efficient as it can be, and then the query is actually executed. Stored procedures only have that one step. As they're stored and saved as a stored procedure, the optimized version of it is kept. So you don't have to optimize it again is the point. You just execute the query. So that's seen as a bit of a time savings and efficiency gain that you might have by using a stored procedure. All right. And then moving on. So time date stuff. So just to hit this real quick. So being able to work with time, with date detail is important in SQL. This actually shouldn't be there. I won't have it whenever I run the query. That I just forgot to take it out. But this example is pretty simple, pretty silly, but still a good one. So running through the query, we have the date variable. It's declared as a date time, so we know what type of data to store in it, how to treat it. Whenever we do our comparisons, that's important, right? Then we're going to set the date variable using the SQL function getDate. Gets the current date, puts it into that variable. Then we're going to run an if statement and check if that date is less than 6:30, then we're just going to display the date, and then we're going to add a value to the date and display it again. All right. Again, pretty silly example, but just to show it. Let me pull in the lab. All right, so let me pull that in, and we'll run it real quick. Come on. Okay, so I've actually got both queries in here, so I'm just going to run this. And today is definitely prior to the 30th of the month. So I'm going to execute it. We get two results back. First, I just get the date in the format shown. Now you notice it's not just the date of the year, it's also the time, right? And so since this conditional expression evaluated to be true, I went ahead and displayed the time, and then I'm using the add date function or date add function of SQL to increase the date by a day, 1 day, and add it to the at date, which results in now this showing as the 24th, right? So again, pretty simple example, but it works and hopefully illustrates. Another thing that kind of comes up, and again, you can spend a lot of time just showing date time functions, right? But another question that has arisen sometimes is, okay, there's not a lot of ability, or it kind of is difficult to just cut and paste a SQL result that is a date from SQL into Excel, right? So how can we do that? So just one example of a couple, right? So by using this function, the select date and then casting it as a different variable type, you can actually satisfy your need to change the date format to one that you can export to SQL. So let me just show you the result of that. So if I execute this, I get two values, the one that comes directly from getDate and then the other that comes as a result of casting. So you look at it and you see that formatics-wise, it's very similar. We strip off the seconds and so on. If I try to take the one that comes directly from SQL and paste it into Excel, you'll see what I get. Let me pull Excel in real quick. Let's paste it into this to this cell, and not very readable at all, right? Whereas if I just use the casted value, or the value that I cast to small date time, copy that and move that into Excel, it is much more readable. It's exactly what you would expect it to be, right? So again, is that the solution for every scenario with SQL and dates and trying to move them to Excel and so on? No. it is one example so that you know that it can be none. There may be another way that you would prefer to do it, and that's fine, but at least that'll get you thinking about it. All right, and then just another example, we're almost done with the query examples of using not in versus not exist. So we always try to think in terms of efficiency whenever we do queries, right? And so with the sub-selected query, especially using not in, we have to completely query this data set into memory first before we can do the not in comparison, right? And that works, no problem. It just sometimes takes a little bit, especially if this data set is really, really large. There's another option that we can use where not exists and then run this data set to figure out what's there. Quickly, with a bit more efficiency, do the comparison so that we can get a result quicker, right? So for large data sets, if you're running into challenges with performance or taking a long time, try using not exists and see if that's a better experience for you, okay? All right, so last thing that I'll talk about in this particular section is constraints. So not really a query per se, but constraints is a concept. Tried to illustrate it here, probably not the most perfect illustration in the world, but constraints is a function of SQL that kind of locks data between tables together so that if you can't make a deletion in one, that would affect the other unless you do it in the right way, right? So there's this concept of a primary key. There are also unique keys and different kinds of keys that are on tables where you want to protect that data. So here on table 3, for example, we might have a key on the item key value, okay? And so if I try to go and delete this particular value from the table, I can do that with table 3 because this is where the constraint relationship starts, right? It will just cascade down to the other tables that are holding related data. So in the ConfigMgr database, an example of a good table 3 would be system underscore disk. That's a table where many or where key constraints are set to protect the data from being improperly removed, right? So that has impact over into inventory tables and the like. But if you go to one of the child tables and try to delete the record directly from there, so deleting from table 2, because this constraint exists, there will be a protection mechanism in place to prevent you from altering the table data here because it would have effects that you don't particularly want. Right now, again, not the best way to illustrate this, hopefully understanding the concept. There are ways to do that if you need to. It's something you want to be very careful about and such, but just understand what constraints are. In terms of some more advanced topics, right, there are just a few things I'll mention here. So I've already shown you and talked about a bit what stored procedures are. I've talked about the optimization of the parameters and so on, so I won't belabor the point here. Stored procedures will run. They can do a variety of things. Mostly stored procedures are kind of read-only operations, not all the time, so be very careful with them, especially if you're trying to run them live in your database. Functions are similar to stored procedures. They take parameters as well. Functions, just like in regular code, will always return a value. So if you look under programmability and look under functions, I'll just open table define functions, right? They look very similar, but they will return a value. There's select statements in here and so on, right? So you can go and see what they are. But functions and stored procedures, while similar, are different, right? So you can see that it's returning data. It returns a table in this case, as an example, right? And then beyond that, I did show you an example as we started where you can actually calculate data as a part of a query. So where was that? I can't remember it now. Probably here somewhere. Flip through it. There, yeah, this is where we're using some calculations to run your select. You can use calculations elsewhere as well, right, in different kind of query formats. But that's really what I wanted to walk through here. So we will wrap it up here, and we will talk about more SQL topics in the next session. We'll see you.